আচ্ছা, গো লাইভ এখানে দেখাচ্ছে। তো এবার জাস্ট লেট মি চেক ওয়ান্স with the link if we are live. Yeah, so we are live. Okay, so welcome everyone to this amazing session on GenAI by Murughallar. So he can basically speak all languages: English, Hindi, Bengali. So he'll be taking your session today. And yeah, those are not the only languages that he speaks of. Python is something that he writes and he speaks and he sleeps and he eats everything. So that's why probably he's kind of the best guy for us to take the session on the GenAI, because whether it's Python or you're implementing in JS in today's time, knowing how the transformers work, considering the use of ChatGPT, the use of GitHub Copilot, but understanding that underlying architecture, making your own apps using that, because whether you go somewhere, you are making a final year project, or it's the hackathon, it's your first hackathon, like Hello World Hacks. So this is something that you will be using in your projects. So how to implement? Yeah, hello Vittal, hello. Yeah. So how to implement and all that will be shown by Murg. He has been the former data science and machine learning intern at Webble. It's a government entity in West Bengal, and he had been working there previously as an intern. And he has gone to various hackathons. He understands the pulse of the judges, that how a judge sees a project, especially when it comes to implementing GenAI, because it's not only about the API that I have the OpenAI API and I just implement it. It's all about the codes of tools that he will be showing you guys how to do it, how to integrate it, how to make just one single API call, but in a full stack environment. So yes, that's Moyuk for you guys. Now, without further ado, probably I'll give it to Moyuk to start with our today's session on GenAI. So Moyuk, you can continue.
So thank you, Shagni, for the wonderful introduction. Thank you, everyone. And so now, without wasting any more time, let us now delve into the topic of Gen AI. Okay. So directly, like everyone does in every session, like how many of you actually know about generative AI? Like I want to know actually, like what is generative AI, or how many of you actually have heard about the term generative AI? Can we just write in the YouTube chat once? I can see your chats. Like what is generative AI or what is something like that? Anyone? Anyone you can write? I will give you like 1 to 2 minutes, and then I will give the definition of generative AI. Yes, I can see the chat. I think.
Yeah, I can see the chat. No worries.
Okay, okay. So actually, what is generative AI? It is actually a subset of like data. It is an intersection of data science and a subset of deep learning. Okay, like we all know that. I can show you one very common image which we all know about the Venn diagram. Okay, I can show you one Venn diagram here. Just wait. AI, ML, and DL. I think you all know this Venn diagram. Let me show you it once. This one. Okay.
Yeah, but your screen. Achha,
Yeah, I know. So this diagram, if you search it in Google, okay, this is the AI part, this is the ML part, and this is the DL part. So now what is AI? AI means like if you want to do human tasks, but by machines or computers, we will use artificial intelligence. Now what is machine learning then? Machine learning is nothing but working with predictive modeling. Like we want to generate some, like we want to make some models which can predict on basis of some data. So we have to predict based on some data. So we have to train some models on the basis of that. So we can use ML for that. Okay, that is machine learning. So now what is deep learning? Deep learning means like it is actually based on artificial neural networks. I hope you have all heard about the neural network part, right? Like if you think like what is a neural network, it is a kind of an mimicry of the human brain. Like if you want to mimic the human brain, then it can be like it is written here, algorithms and mimics human brain to incorporate intelligence into machine. Like it is a kind of artificial neural network. I'm not going into the depths of it today because it will go out of the scope of the session today. But for your knowledge, like I would say, like deep learning is nothing but kind of training on massive amounts of data, but in a kind of there will be hidden layer, input layer, and the output layer. So it is something like that of artificial neural network. Let me show you one example here. Artificial neural networks. Like Google is the best companion for this kind of things. Artificial neural networks. You can get it once. See like here. Like it is the input layer, it is the hidden layer or the middle layer, and this is the output layer. So like every layer is interconnected with each other, and we will pass the data, and so it will train on these kinds of data. So it is actually single layer neural network. Okay, but when we talk about LLMs, it is nothing but multi-layer deep neural networks. So it is something we will discuss about in today's session. Okay. So now let us go back to this topic. Like, so GenAI is nothing but a subset of deep learning, but with an intersection of data science. So it is kind of like you can say generative AI does not only contain LLMs. Like nowadays, if you ask someone like, "Do you know generative AI?" He will tell you, "Yes, I know generative AI, and I have worked with LLMs." LLMs is the only thing nowadays people actually correlate with Gen AI, but that is not the thing. Generative AI you can correlate with like image generation models also, audio generation models also, like Whisper AI or like Stable Diffusion models. So generative AI is a vast topic. Nowadays, like many people say, like generative AI means only LLMs and all those things, but generative AI means a huge array of topics like Stable Diffusion, or maybe like flux models, or maybe something like we also have like video generation models nowadays, like animate diffusion. So there are lots of models like that. Okay, so that is Gen AI. But before understanding generative AI, let us look about the history of generative AI. Like I have made this Notion notebook for you all. Like I will share this notebook with you. But once when we start the coding part, then I will share the notebook. But now for this time being, like I will show you this notebook and I will teach you from this notebook only. Okay. So now, before understanding generative AI, we will go to the history of generative AI. Like we will first see the genesis from Eliza's cows to transformer takeover. Then inside the AI kits of the transformer architecture, and then the RAG architecture, and then some AGI whispers like Gemini Ultra, then Q Star, Llama 4 Behemoth, and all those topics. And then we will have the project part, the actually the coding of the project chatbot. Okay, we will make a RAG chatbot here, so we will see the code part of that, and then there will be a Q&A session. Okay, for you all. So before starting, let me ask you one question. Like anyone of you know, like what is the basis of actually like how chatbots evolved? Can anyone tell me in the chat? Like I know you are seeing the answer here. Like Elisa is the chatbot, but anyone know what is Elisa or what is that? I can see the chat right now, but no one is giving any answers, I think. Okay, no issues. I'm showing you one thing right now. Just wait for 1 second. Let me show you one thing here. So if you want to see what is Eliza, I will show you one in demo here. So this is Eliza. See. So if you go to this website now, if you go to this website, like here you can see one masswork.at, I think that is Eliza bot. It is actually the foundations of chatbot. Like Eliza worked on pattern recognition. Like I actually notebook once. Like it was like based on simple pattern recognition, like string matching and all those type. Like if I give one input and in the input is there's about like I feel sad, then the reply will be why do you feel sad? And if I give like mother in my user input, then it will ask like tell me more about your mother, but it will not give the not give the output on the basis of our question. Like if you want something like I want to learn about LLMs, then it will give like why do you want to learn about LLMs? Like why do you feel sad? So it will actually not give the answer like that. So let me just show you one demo here. Like if I go to website here.
Okay, Moyuk, probably your voice is little bit having some noise. Means, just can you check your cable once?
Okay, no issues. I'm just checking it once.
Headphone once.
Uh, so I'm going to settings and noise cancellation. I think I have to on it. Is it having the same problem?
Yeah, now it's better. Now it's better, much better.
I think now it is noise cancellation on. Okay, no issues.
Yeah, yeah, yeah.
So now here. So now if you want to see Elisa how it works, like if I want to learn about LLMs and I write here like I want to learn about large language models or LLMs. If I give an enter here, now see, what does wanting to learn about LLMs have to do with this kind of discussion? Now it is not giving me the answer. Like, I want to learn about LLMs. This is my problem, but it is not giving me the answer because it is trained on simple pattern recognition. Okay, like let me show you once here in the Notion notebook. It is trained on simple pattern recognition. Like if there is some pattern in the input string, then it will give the output on the basis of that pattern. It is already trained on that pattern. Okay, so it is actually not. It will actually not understand the human emotions, what we want to learn, or what we want to actually talk with the LLM. So that is the problem with Eliza. But there was a very interesting effect known as the Eliza effect. Like people knew it was just code, but they anyhow share their feelings. That this shows our innate desire to connect. Now I think you can just know now you can just understand what does this mean actually, right? Because people knew it was just code, but shared the feelings away. So now you know what I mean. Want to mean? That is a very interesting thing. Okay, they knew it, but still they confided in it. Okay, so that's it. But then next part is like how does the LLM actually evolve, right? How did the LLM evolve? So now at first after ELIZA, we had RNNs and LSTMs. Now what are these terms? Like this will be technical jargons. Like you'll be afraid of this, I know very well. But actually, these are nothing but RNNs are like recurrent neural networks, and LSTMs are long short-term networks. Okay, but what does this models do? Like they were like with the beginning for chatbots or LLMs, but actually they had one problem, and that problem was like they could not interconnect words. Okay, like they had like one problem, like they could not understand the meaning of words with
Okay,
respect to
Moik,
another word.
uh, Moik, just can you
Okay,
check your mic once, because means when you are speaking properly, then the voice is kind of breaking like that.
okay. Hello, is it audible right
Yeah,
now?
this is the mic is having some issues.
Oh my god, what can I do right now? I don't know because I have only one headphone right now.
Okay, so maybe okay, okay.
Can I
Are you in
continue
desktop
or
or laptop? Right, you are in desktop.
laptop? Laptop. I mean laptop.
Okay, just maybe you can do the free hands on, like means you can just remove your headphones and you can keep it normal using the laptop mic. That would be fine.
Okay, 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 okay. Got it.
Yeah, change it to laptop mic. That would be better. You are on mute, by the way. Yeah, you can. No, your voice is not coming. No, no, your voice still isn't coming. Just you can just come into the streamer and check the mic array from over there. Hopefully,
Hello, am I audible? Hello, am I audible?
yes. Now you're audible. Now it's fine.
I think my voice is not cracking now.
Yeah, now it's okay.
Okay, just let me check once again. Automatically adjust the volume. I think now it's okay. Hello.
Yeah, now it's okay. Now it's okay.
Okay, okay. So let's continue.
Yeah, you can
So like we
continue.
have studied about like yeah, ELIZA, but now let us go into RNNs and LSTMs. Like what was the problem with RNNs and LSTMs? It was like RNNs had one problem. So RNNs, the problem was like it couldn't actually understand the meaning of one word with respect to the other words in the sentence. Like it couldn't correlate words with other words in a sentence. So that was a problem with RNS. Like it couldn't correlate words for huge sequences of sentences. Okay. So for solving that problem, the transformer architecture came here. So what was the actually problem? How did they actually solve the problem of connecting the words? It was like they used a mechanism known as the self-attention mechanism, and this was the game changer in the field of AI and LLMs. So let us move on to this architecture. But before that, let me give you some actually references here. Like what can you look up and what can you see there? Like the Transformer Big Bang. It was actually released by Google Brain's Attention is All You Need paper. You can check it here and let me show you once. Like here, I think it can be shown to you. Yeah. So this is the paper. I think attention is all you need. This is the paper. You can just Google it and then you will get it in archive. You just view PDF. You will get the paper. And this picture is taken from this paper only. Okay, like this picture which I showed here. Like after which I will show you right now. This picture is taken from here only. Like this paper. Okay, where was it? I think yeah. So this is the paper. Attention is all you need. It was developed by Google Brain. It was released by this Google Brain. You can search it here also. Google Brain. What is that? Google Brain. So Google Brain team is like Google DeepMind, but it is something different because it is developed by Google only. Like make machines intelligent, improve people's lives. You can see other papers also released by this organization, and then we have in our pipeline we have the transformer paper, and then we have the first RAG paper, retrieval augmented generation, which we are going to do today. The RAG chatbot. We have to develop this chatbot today. So for that, we are going to develop this. But what was the foundation of this RAG chatbot, right? The first paper was this one. Let me show you once. This was the first paper. It was actually by Patrick Lewis, Ethan Perez. You can just see their names, and this is the PDF. They proposed formally the first retrieval augmented generation, and this was the paper. You can just see it. I will share give you all the links. Okay, no worries. In the Notion notebook only they are provided. If you want to study, you can just study from those papers. Okay. But now let us move on to the inside the large language model, how text is generated. Okay, this is for LLMs. Like you can study this for like for your own knowledge, but I will just tell you it in simple mechanism, like simple words. Okay, I will not go into technical jargons because today I want to make it a very simple session for you all. Because I know many juniors are also here, my juniors, so they won't like me telling so those technical terms and jargons. So I would just go in with simple terms so that you can understand. Okay. So first we have the inputs will be gone like how does input actually taken here? Inputs are like you will give some text query. Okay, like let me show you once. Yeah, the input is like if I give a text query like explain quantum physics simply. Okay, so this input text will be broken into basic tokens or units. Now what can be tokens? Tokens can be words or subwords or punctuators or punctuations. Okay, so it will be like explain will be one token, quantum will be one token, physics will be one token, and simply will be one token, and dot will be one token. Now it is a punctuation, so it is one token, and these are just words, so it will be one token. Now if I wrote something like uh, something which consists of two words, like there are something like something is a sum and thing, so it will be broken into two subwords, and then it will be taken. Okay, so these are tokenization, and so after tokenization we have the process known as embedding. Okay, so before input embeddings, this will be the input embeddings. Now, how are input embeddings calculated? There are something known as some other functions like embedding functions. There are many embedding functions. I'm not going into the depth of those functions, like what to vec or globe vector representation, but those are something not for today. So I will just going over this like very short, very simple words. So it will be like each token is converted into a numerical vector. Okay, like what is a vector? It is a kind of array or list of numbers, numerical representation of text, that is embeddings. So it is a high dimensional space like this. This is a very important thing. High dimensional space. Now what does it mean? Like when we were in class 11 and class 12, now we used to study like what are vectors, right? We used to study about vectors. Like it was vector was like three-dimensional physical quantity. Like it has why three-dimensional? I'm telling because it had I, j, and k, right? I cap plus j cap plus k cap. So it has three dimensions. But here in mathematics or data science, in vectors it can be multiple dimensions, like high dimensional space, like it can be 768 dimensions, other dimensions also. But in ChatGPT or GPT, it was first pretended in 768 dimensional space. So I went with 768 dimensions only. So yeah, that is one interesting fact for you guys. Like it can be like quantum will be an array of numbers, but the numbers will be, length of this array will be around 768. Okay, that is it. So next is adding sequence information. Now yes, very very important. Now I'm not going to the depths of this, but actually what it does is it's like you have given the input query. Okay, it has broken it down into tokens, and then the tokens are now represented into embeddings. And after this part, these things are now actually stored in an ordered format. To actually keep the preserve the order or the sequence of the original sentence, we have to actually use this kind of positional encoding. Okay, there are lots of positional encodings like rotary position encodings or other things like that. We're not going into the depths of this, but for your simple knowledge, I'm going to tell you that this is just to preserve the order of the words in the sentence or the sequences. Okay, that's it. So now after this, it goes into the encoder. This is the encoder and this is a decoder. Okay. So now I'm not going to explain you all this the technical things because it is going to be a very large session today. Then we don't have so much time. Since we are already running short of time, I'm going to just tell you in short these things. Encoder is nothing but like it actually understands and then it passes into the decoder part. Okay. And what does decoder do? This is a decoder. Okay. This part is a decoder, the right side, and left side is the encoder. Encoder, what will do? It will first take the text as input, and it will then first try to understand the logic or the attention mechanism. Like it will first try to correlate the words with other words and give some attention scores. Okay, like here you can study for your own knowledge for later. Okay, how it actually works, the encoder part. It will like first relate the input tokens or correlate the input tokens. It will make some vectors like q vector, k vector, and v vector. Q vector is for query vector, k is for key vector, and v is for value vector. Okay, so these vectors will then be passed to the decoder part, and the decoder will try to generate the next token. Like if you want to classify, na, you will always use encoder based architecture, and if you want to predict or generate, na, you will always use decoder based architecture. So Llama 2 was actually a decoder based architecture model, but GPT was also decoder based. But if you learn about BERT, na, it is actually bidirectional encoder representation of transformer. So it is actually uh, encoder representation for classification tasks. So these are some of the things like which you actually need to understand before learning about LLMs. So these things are like I told you very simple words, right? This is for classification. This is for like generation, and this is after that. What we do, we just pass on to the linear layer, and then with the softmax layer, and the output probabilities will be calculated. On the basis of the output probabilities, you will get the output tokens. Okay, that is it. So that is all about this encoder decoder architecture. Because today I don't want to actually waste time on this, because if you wasted much time on this, then you will not be able to code the part. Okay, so you have to code everything today from for the rack chatbot. So I'm going to explain you that also, but before that, let us understand these things for just simplicity. Okay, to make the things simple for your later understanding. So this was the encoder decoder part. How it works, you can just study it later, because this is a very huge paragraph here. I've written it for you guys. You can just study it once. Okay, no issues. Now this part, okay, size versus scale and the parrot problem. Like it is something like, what can I say? You can just imagine, na, if it is a big model, if it has more parameters on which it was trained. Like nowadays there are many models with parameters like 80 billion parameters, 70 billion parameters. Maybe some models are trained on trillions of parameters. So the more the parameters, the better the model is. So learns more complex patterns, sounds more knowledgeable. But what is the limitation? Costs millions of dollars to train and run. But what are the advantages of smaller models? They are like faster, cheaper, and can run locally. Like you can use Olama to run them. But the problem is with smaller models is that if you have to like if you give some more intensive tasks which contains like very difficult mathematical problems or something like that, it will not be able to answer it very correctly. So that is the limitation. Like knowledge cutoff with smaller models, and there are some like some can hallucinate also. Like it can generate their own answers. Like they will generate new answers. Like one example is like if I give one question like in a rack chat, but only if I give one question like out of the box, then it will like it was not trained on the data, right? Like if I give one question which on which it was not trained, then it will give some answers like it will generate new answers. So that is like something which we don't want. We want the correct answers, na. So for that reason, people nowadays use RAG, retrieval augmented generation, for giving the up-to-date answers. Like they will give one knowledge base or some kind of they will give some external checking, like what you can say, external documents, which you can actually find it out from the answer, and then it will give the right answer. So that is why people use RAG nowadays. So yeah, and yes, they can read your private docs also. Like if you share your private docs with retrieval augmented generation, then they can read. But if you train on LLMs, they can't read. Okay, that is the thing. So now we are going to study about RAG, retrieval augmented generation. Okay. So these things you can read on your own, but I'm going to just explain you the architecture, how it actually works. Okay. So let me just zoom it once. Okay. Yeah. So what does actually retrieval augmented generation mean actually? Okay. Let me just give you a retrieval augmented generation. What does it actually mean? So retrieval augmented generation. What does it mean? We give some document to the LLM. We want the answer from, like, if we want to summarize some document for our own convenience, or we have a very huge document and we want the right answer from that document. We are not, like, we are very, what can I say, in हिंदी क्या बोलते हैं, बहुत आलस लग रहा है तो मुझे डॉक्यूमेंट पढ़ना नहीं है, तो मुझे जस्ट उसका आंसर चाहिए, पर मुझे डॉक्यूमेंट देना है, तो मैं क्या करूँगा? I will use one RAG chatbot. I will use an LLM, and I will provide the resource as a RAG document to the LLM, and then from that I will get the answer. Like, so RAG is used for that purpose. Okay, so retrieval augmented generation means from the retriever, I will retrieve the relevant chunks, and I will then contextualize it with a given query, or I will augment it with a given query, and then the generation will be like augmented generation because I have already contextualized the prompt. So now these terms I know it will be quite confusing for you, but let me make it clear. Okay, so what does it actually mean? Contextualize means you're passing the context with the query. Now, what is context? Nothing. Context is nothing. Context is just the retrieved relevant chunk. Okay, the retrieved relevant chunk is the context, and when you augment it with the query and pass it to the LLM, when the LLM generates the answer, it is known as augmented generation. And so that is known as retrieval augmented generation. This is a simple term. I hope now you got it. What is retrieval augmented generation? So now let us actually understand the workflow, the pipeline of the process. What is the architecture of retrieval augmented generation? How it actually works. So first of all, what we are going to see is that there are various data sources. Okay, like these are data sources. Like it can be document, HTML, docx, PDF, anything. Now we have to first pre-process the document. Okay, so what we have to do, we have to first extract the text from the document or extract the data from the document. So for that, we will use some data loaders or data loaders like doc to PDF, doc to text, PDF to text, by PDF loader. You will use them to convert or extract the text from them or data from them. And then what we will do, we will not pass all the data at once because the LLM will not be able to take all the data at once, because LLM also has something known as context window, which actually limits the LLM from taking lots of data, because attention architecture is good, I know, but attention architecture also has some limitations that it cannot actually predict on a basis of a huge number of tokens. Like if we increase the input tokens to a huge number, then it will not be able to predict on the basis of that. So to limit these tokens, we use chunking. One process is called chunking. So what we do, we use chunking for those. There is also like recursive word text splitter or recursive text splitter. There are lots of text splitters, but for this use case, to today's use case, we will use recursive character text splitter. Okay, so this is chunking part. After chunking, you will use the embedding model for converting it into vector embeddings, like what I told you there at that part, like how embeddings are actually made. Okay, so how embeddings are made? They are actually nothing but arrays of numbers. Okay, so first of all, we will actually chunk it, then we'll convert it into arrays of numbers, because LLMs can't actually understand text. LLMs are nothing but mathematical functions. Na? Models are nothing but mathematical functions. So if you use mathematical functions, we will always have to give the input in form numbers only. So for that, we use actually vector of numbers or array of numbers that is known as vector embeddings. So if anyone asks you what is vector embeddings, you will say it is the array of numbers, or you can say it is a representation of text in numerical form. That is vector embeddings. Okay. After that, we have what is known as the vector database of vector stored. How it is actually created? Like the embeddings are created into one vector storage. Okay, they are actually accumulated into one vector storage, and then using the indexing of the vector storage function, you will actually get a semantic index. Now, what is semantic index? it actually contains index vector embeddings. Now, why do we need index vector embeddings? Why not only vector embeddings can help us? Because when we actually use the query index embeddings part, na, then we use something known as semantic searching. So for that reason, we will use the semantic index. Why index? Because index will actually help us to facilitate the process of semantic searching. Like semantic searching means it will use some kind of mathematical techniques to understand the relation between the keywords as well as the words. Okay, so it will actually try to find the similarity between them. So to find the similarity, we will use semantic index and semantic searching techniques. Now let us go into the user part. Okay, this was the model part. Now how the user will actually interact with the RAG system, we will see. So this is the user. It will give some query to the model or LLM. This query will then be converted into the query embeddings. Like here, the text chunks were converted into vector embeddings or text embeddings by the embedding model. Here also, the query or the query part will be converted into query embeddings by the same embedding model with the same embedding function. Okay, and after this embedding function is converted embedding query into embeddings, we will then use a semantic search to find the similarity between the query embeddings and the index vector embeddings and the vector data store. And then the really relevant chunks will be retrieved from the vector store, and these relevant chunks will be passed to the query embedding query as well as it will be actually added to the query, and then this adding of the query with the retrieve relevant chunks is known as contextualization, because we are actually augmenting the query with the relevant retrieve relevant chunks or the context. Actually, this retrieve relevant chunks is also known as context. Okay, so when we are actually contextualization, this happens here, and when we are contextualization, it happens after that. We pass the contextualized prompt to the LLM, and then the LLM generates a response with respect to the contextualized prompt, and this response is then passed to the user as the final output. Okay, this is the final response. So that is what is the process of RAG. Like first you give some kind of data sources, then these data sources are pre-processed, then they are chunks, they are chunked into chunks, and these chunks are then converted into embeddings, vector embeddings. This vector embeddings are then stored into vector database or vector store. Then they are indexed. The vector database, vector embeddings are then made into vector index vector embeddings, and then the user will ask a query. This query will convert to query embeddings. Then semantic search will take place. Now, what can be semantic search? Like there can be lots of search techniques. Like some are like um, squared L2 norm. Some can be like they're very technical terms. You don't need to understand it right now. But for default semantic search is like squared L2 norm similarity search. That is the default of the database which you're using now. For ChromaDB, it is squared L2 norm. For other database, it can be like for Pinecone, it is like cosine similarity also. I will show you all the formulas for ChromaDB also. Okay, don't worry. And then you have the retrieve relevant chunks from the data set which are retrieved. They are then passed on to the like query to augment it, to contextualize it, and after this contextualization takes place, then they are passed to the LLM to generate the final response. So this is the RAG pipeline. Okay, so you can study this on your own because I've written it for you only. I will share this. Okay, this notebook I will share to you all. No worries for that. But now let us move on to some interesting whispers like the AI frontier. 2024 to 25 highlights and AGI whispers. Now, what is AGI? AGI is the most powerful part of AI, which has not been published till now. But people are like claiming that they've already achieved AGI. But still, I think AGI is not achieved till now because AGI means artificial general intelligence, which we can compare to human super intelligence. Okay, so AI machines are not so super intelligent. Like they can perform human tasks like they can perform cognitive tasks with so ease. But still, I think at this point AGI has not been achieved, but in future it might have been achieved. But still, there are some speculated models which have, like you can see, these models which are actually told to have achieved, they claim to have achieved AGI, but still, I think they are, maybe they have achieved, but I think they have not yet achieved AGI. Okay, so like Google has claimed like Gemini Ultra to be one of the most powerful AGI models of it. Like it is multimodal also, and it has been released because if you take the Gemini advanced subscription, there you will already find the Gemini Ultra model. You can use it. Okay, that is one of the most powerful models by Google Gemini. Then there is one speculation like OpenAI Q Star model or the Q Star project, more to be more precise. Now, what is this Q Star? You can study it from here, but for your simple understanding, you can just understand that it would actually works like from reinforcement learning, like Q learning and search algorithms which you have already studied, like A star. Like in our, not you already have studied, like We have already studied because in our third year we had already one session, like one subject in like AI and algorithms. One subject was there in our college semester. So in that semester we had learned about A star. Okay, so actually Q star means Q learning and A star. So that's why I told. Okay, so no worries. That was about Q star. You can learn more about in this report. I will show you this report once. Wait. Okay, so this report, I think it was here. OpenAI report. I think this is the report. I've given the link also. You can just go with the link here. After being contacted by tutors, OpenAI, which is declined to comment, the internal message to staffers a project called Q Star. So this is one of the most speculated and most powerful AGI models of OpenAI. Okay, they speculated. It's a rumor. I don't know it is actually released or not, but it is speculated to be one of the most powerful AGI models. And then for Llama, we have the Llama 4 Behemoth model. Like it has around 288 billion active parameters. You can obviously see how much powerful this model is. Like it is a kind of mixture of experts, I think. Yeah. In photo performance, like yes, it is a mixture of experts. Like it has been like mixture of experts means you can understand like it is a kind of ensemble of other LLMs. So it is kind of that kind of model, mixture of experts. And it can be used to distill other models also. So that is about Llama 4 Behemoth. So now let us learn about something which are now booming nowadays. Okay, like Anthropic has released recently its model context protocol, which are now booming nowadays. Like it has some kind of MCP host, and in the MCP host we have the MCP clients, and from there we connect to the MCP servers, and from there we have the MCP tools. Yeah, you can just study about this on your own. But for today we will be doing one project known as RAG chatbot. Okay, so let me just go into the project part now because we are already running short of time. 8:38. Okay. So yeah. So now let us make the project. So now I think I should share this link of the uh, Notion notebook with you all in the chat. Okay. So I'm just sharing the notebook link with you all. Just wait. Just 1 second. Give me 1 second. Uh, where is the link of the Notion notebook? Yeah, I got it. Copy link and then share it here. Okay. So I think this is the link. I think it's not posted. Shagni, can you just once check if the link is posted or not of the Notion notebook? Because we're going to code the whole project now.
Okay, no, I think it's not. Maybe
Okay,
you
okay.
can share me the link. I'll share it.
Okay. No issues. If let me just try it once more. If I can just post it once. Uh,
Yeah, yeah, check.
just once more. If I just try to post the. Is it posted?
No, I don't think. No, your comments are not being posted. I think.
For me, it is showing it is posted right now. I don't know.
I think you have
No
to.
issues.
Yeah,
No
you
issues.
can share.
I'm sharing the link with you. Okay, I'm just sharing the link with you.
Sure, sure.
So this is the link. You can just post it once. Okay,
Yeah, yeah,
so that people can actually do the hands-on with me at the same time. So I'm actually sharing the link with them.
yeah. Sure,
You
sure.
can just pin the link at the chat. Okay. Yeah, that's
Yeah,
it,
I have
guys.
posted.
So guys, just go to the link. Go to the link and just open the Notion notebook once. I want to see how many of you have already opened the notebook. Just tell me. Okay. I think they have already opened the notebook, right?
Yes, yes.
Okay. Okay. Opened. Nice. So now I'm going to show you one thing before actually going onto the Jupyter notebook. I'm going to show you how to make the project structure for the code. Okay. So let me just open it. Yeah. Okay. Someone is writing something, I guess. Just opened. Okay. Nice. Got it. So let me just write the code part here. Okay. So let me open the Notion notebook once. I'm going to write it here. Make it this time and then the Notion notebook. I think this one is not this one. Okay, this one. Yeah. And the project structure which I opened, I think I should keep it here. Mm-hmm. Okay. Okay, nice. So what we will do, we will actually first make a, sorry, you can just make a folder, okay, any folder, and you can just, for my convenience, I've written it as rack chatbot EWH. You can just give it any name, like rack chatbot or anything, okay. Just give any name to the project. But before building the chatbot, we will first go into the fundamentals of LangChain, and then we'll go to the Stack chatbot part. But for that fundamentals of LangChain, we will need the .env file. Okay. So for that reason, I'm actually going to share you the this part also. Okay. No worries. So before understanding, let me just do one thing. Let me make the project structure for you all. Let me just do one thing. Let me just go to this part, the project structure part here. Just go a little bit down, scroll down a bit. Like I think it's not working here. Yeah. Scroll down a bit and go to this part. Okay. This part. Yeah, project structure.py. Go to this part, make one file here in the folder, name it as project structure.py. Okay, because we are going to do modular coding here, so I'm going to show you the whole process of modular coding. So no worries. Like you can just click on this copy button here. Okay, what happened? I don't know what is happening right now. It went at the first. Okay, I think this part was that. Yeah, something wrong is happening, guys. Wait, no worries. I'm opening the link from here only. No worries. Okay. So let me just close this once and just click the link here. I think now it will work. Yeah, now it is working fine. So let me just open this part once. So this is a project structure. Just copy it once. Okay. Just copy it and paste it here. So now what we are doing here actually is nothing but we are creating the project structure. Okay. Like we are going to do modular code here. So for this reason, why in Python, if you have studied about Python, might know this one. By import OS module, we're importing it. Then on the path module, we're importing the path class, and then we're creating the list of files. What will be there in our project structure? What will need in the React chatbot structure? Okay, and then you have the this for loop. It will actually create the project structure for you automatically. Okay, this is a kind of automation, cheap automation, I would say, but yeah, automation. So how we will run this? Okay, so before running this, we will need some other things also. What things? We will need something. Well, okay, let me just run it once. Okay, no worries. Run this once. New terminal. I would say you should give the name of the folder name just as I'm giving. Okay, then it will be easy for you. You should give the src folder name as rag app. Okay, for ease of use. What I will do, Python. Just write this in terminal. New terminal. Python project structure dot py. Okay, just write this. Python project structure.py, then click enter. Then it will ask for enter source folder name. Just give there anything. I'm giving it as rag app. You should give rag app only, rag app for this session only. Then you can just, I will just tell you how to change the name of the source folder name and what you have to make change in the code app code also. Okay, I'll tell you everything. But for the time being, just keep this as rag app. Okay, then press enter. it will create the folder structure for you. See, it has created the structure. GitHub, then notebook, drag app. It will create the folder structure for you on your own, on its own. Okay. Now what you will do? You will close the CMD, and then you will have to create this env. Okay, env virtual environment. And for that also I've given. Okay, this one is not here also. So what you can do? I have created one env file. Okay, first you have to copy paste these requirements. Okay, these are actually very important. So copy these requirements and paste it here. And one thing I'll tell you, for local deployment of the app, you don't need this PySQL like 3 binary. This is required actually for Streamlit deployment. So for local deployment, I will comment this out. Just comment this one. And for Streamlit, you will need this. So I will tell you what to do there. Okay, no worries. So for the timing, just comment this out, comment this part out, and just write this requirements from here. And then what you're going to do, we will create a very quick and short setup.sh. Okay, what is sh? Shell script. And what is init setup? We are going to create a environment. For that, I've created an init setup.sh. Okay, just copy paste this init setup and then paste it here. Copy this and then paste it. Okay, just okay, no issues. And then what you're gonna do? You're gonna run this. Okay, but before that, let me just check one any more things are required or not. Yeah, one very important thing is you're going to require .git ignore. Okay, for that, I just create one file here, just guys. In the root folder, just click in here and then this one, then just create one file known as git ignore. Okay, then click on here and just paste this text from here to the .ignore file like this. Okay, I think now this should work. Yeah. And one more thing, you need to make up your .env variable. Now for this, I actually would prefer you to do one thing. Like if you have it all right, otherwise I'm going to show you how to create your API keys also. But for the timing, just copy this, paste this and create one .env file here also. .env. Okay, I'm creating one .env.sample. You create .env only. Okay. .env.sample. I'm pasting it here, and then I'm creating one .env folder also. .env file also .env. .env. Okay. So in here, I will paste my original file, original things. So just copy paste this one here. You just need to create .env. Okay, and then I'm going to tell you what you're going to do with it. Okay. So for this, you will need some API keys. Like one is the Grok API key. You can just go it here, get it here. Grok API keys. No, wait, let me just do one thing here. Grok API key to. So Grok API key. Yeah. So if you go to Grok console.grok.com/keys, okay, you will get the Grok API key here. Just remember, click on create API key. Okay. So from here you will get the Grok API key. Just copy paste the Grok API key from here. Okay. And then you will get the Grok API key for this one. Langsmith API key is optional. For this project, you won't need this Langsmith API key, so I'm just cutting this from here. Okay. It's not required for this project. And then Nomic API key is required. So how will you get Nomic API key? I'm showing you once. Nomic API key. Nomic Atlas actually. Nomic Atlas. Okay. Just open it once. Nomic Atlas. This is the Nomic Atlas. You can just open it once and then sign in. After signing in, there will be a dashboard thing here. Just go onto the dashboard in Nomic Atlas. Then you will go into the settings. Then API keys. And then create new API key. Okay. Yeah, I've already created one API key for this session today. So it is the Rack Chatbot API key. So you will need to have create an API key, but I don't need because I already have created one API key for this project today, especially. So yeah, that is all the things you need to do, and that is all. Okay, just quickly go and create an API key once, and just give me a confirmation here in the chat. I want to see how many of you already have created API keys here. Like, just give me a quick confirmation. Okay, I need a quick confirmation here. Like, how many of you already have created API keys? like Grok API key and Nomic API key. If you already created, then I'm going to show you the next part, like how to proceed with the next part. For the time being, I'm just copy pasting my API keys from there into this file. Okay, no worries. Okay, so let me configure my API keys once. I can't show you my API keys because API keys are not to be shown, of course. So yeah. So you guys can just sign up and create API keys. For the time being, I won't share my API keys because then I will get rate limited. So for that reason, you can just create your own API keys. I'm going to put my API keys here, and then I'm going to come back again. Okay, these are my API keys. Done, I think. Yeah, it is working. Fine. So I think it is done right now. API keys are filled up. .env.sample is done. .env is also done. Perfect. Okay, I can't show you my API keys, of course, for security reasons. But yeah, that's it. Okay. This is my folder structure. It's created. Okay, everything is done. API keys are also done. So now what we are going to do is use this kind of code. But before using the code, we are going to do what is known as simple the fundamentals of LangChain. Okay, we're going to look at the fundamentals of LangChain. For that, let me just go here. For that reason, what you're going to do is, yeah, from this, go to the notebook part, experiments at IPYNB. Okay, just open this one and then create on code. Okay, click on code, and then just copy this code part and then paste it here. What we are doing it here actually is before that select we have to select the kernel. Okay, Python environments. Then I think environment is not created. Okay, no issues. We are going to create the environment right now. For that reason, what we are going to do, we are going to run this init setup.sh. So terminal, click on terminal, new terminal. Just 1 minute. Close this. Then click on CMD is already open. Let me do one thing. Git bash. Okay. Close this CMD. Click on git bash and then click on. Okay. Tell me what is happening here. Exited. Why? New terminal. Okay. Git bash. Click on bash init setup. Okay. Bash init setup.sh. Write this command here in the terminal and then click on enter. It will create the virtual environment for us. Okay. And install all the packages which you require. Yeah. So just let it install the packages and then we're going to run this Jupyter notebook. Okay. I think the Jupyter notebook part is we can start. I think we're already late. So yeah, I think we have only 1 hour left. So I have to go a bit fast. Yeah, so it's installing. Let it install. For the time being, let me show you the Notion notebook. Let it install. Yeah. So you can just see what I are doing here. We are actually checking import LangChain and then print LangChain at version. So we are going to check the version of the LangChain which is installed in the virtual environment. So we have to first select the virtual environment, Python environments, env. The virtual environment is now selected. Okay. So now it is selected. After that, what we are going to do is we are going to run this commands. Okay. So now we can close this very safely. Okay. So now if we run this command now, it will first install the IPy kernel. So let us run the IPy kernel package. So let it install it. We will let it install. Okay. Let it install the package. Yeah, now the package is installed. Now it will run. Okay. So the LangChain version is 0.3.24. Now it is good to go. Okay. So now we will load the environment variables. Okay. Let us load the environment variables. Let us see. Okay. .env loaded. True. So the .env now it is loaded very well. Nice. So now what we are going to do is basic LLM interaction. Let's talk directly to the LLM first. Now this is a very simple LLM interaction. Like what you're going to do is send an input to the message LLM and then it will give the response or output to us. Okay. Let us do it. Send a message directly. Initialize LLM needs Grok API key. We have used the Grok API here. You can use other APIs like Gemini API also, some Manova API also, but I'm used Grok okay for this project. Now let's see what it gives. Okay. Initialize LLM needs Grok API key. And then it will like what was the question? Tell me a joke. Okay. So it gave a answer like why couldn't the bicycle stand up by itself? And because it was too tired. Now that's a good joke. How did it made you smile? Yeah, it obviously made me smile. Okay, the next one. So this is the first example. Okay, let me just. Okay, that is all right. Next example is this one. Okay, tell me a joke. After this, we will like, run this code, parsing the output. Okay, so what we did here actually was, let me show you once. It's the same thing. Okay, but the problem was here if we just printed now one thing. Let me just print one thing here. Print response. Now see what will happen. Now see, got it. So this is a object. Okay, this is an object which was actually given of AI message class. But we have to get the response dot content only, na? So for that reason, okay. If I just printed it like this, you will see that. Okay. Response, if I print it like this, see AI message. So it is an AI message object which contains token content as an attribute. So to fetch the content attribute, we will see like print response dot content. So we'll get the content here. So this is the reason why we're using this one. But if you want to get it automatically, like you can use the str output parser, which is present in the langchain code dot output parsers module. Okay, we are importing the str output parser class from there. Then to initialize the class using an object of it, instantiate the class object, and then we are going to actually print output parser dot invoke. We are actually running the output parser to get the response. So now you will see the response is this response dot content only. Okay, same thing only different ways of writing it. Next, hope that made you smile. Yeah, it obviously made me smile. Next part is parsing the output LLM. Okay. Next is creating a simple chain. Okay. Now what is chain? Chains are like when you want to create sequence of sequence of components, line chain components. When we use the line chain expression language, and you create chains. Okay. Like you can just what kind of connect components, various components of line chain in a sequential order. That is known as chains. Like let me give you an example here. Without an example, you will not understand. So let me try to give an example here. Like we can just copy this one. I think. Yeah. Okay. Now this one is nothing but the basic chain the LLM, and then it will go to the output part. So like what is happening here? You're giving the input. Like here we give the input will tell me a joke. This input will go to the LLM object, and then it will go to the output parser object, and then it will go to the final basic chain. Okay, what is happening? It will invoking. It is invoking. So it is going to the LLM, and LLM is giving the output or the answer. It will go to the output parser, which is the response part. So output parser will give the response to content part, and LLM response will contain the response to content part only. Okay. Now let us try to run it once. See, same thing. Response to content or output parser or the LLM response. We are getting it by LCEL, Langchain Expression Language. This is known as one of the components of LCEL. It's a pipe operator. We can use pipe operator to make chains, and chains are part of a LCEL, Langchain Expression Language. Okay. So that is creating a simple chain. The next part is guiding with prompt templates. Like what are prompt templates used for? They're used to give the LLM better instructions. Okay, like what can I say? Give me an example. Let me give an example here. Like you can see this example, right? See the prompt structure, like topic, like what is actually happening here. From LangChain Coder prompts module, we are importing the chat prompt template class. Then we are using the from template function to create a prompt template. Like this is a template. Okay, like topic will be a template, and then we will actually use like something like this prompt.invoke. Okay, prompt.invoke means what? They're calling the prompt template class or the object to actually fill the topic with the programming part. Okay, now what will actually the output of this? Can anyone guess? It will be nothing but tell me a short joke about programming. Let me run it once. See, tell me a short joke about programming. See, it is actually giving that one. Okay, Tell me a short joke about programming. So this is the output. But this is actually nothing but the messages part, right? If you want to get the final output, we can use the output parser here. Like, see, they have already used it. Let me just use it once here. Now I will give the just direct output from here. See, see direct output. See, so what is happening here is that the first is joke chain. Okay, what is happening? The prompt is giving this human message, tell me a short joke about programming. It is going to the LLM. The LLM is giving the answer, and then it's going to the output parser, which is giving the final responsive content. And this is the responsive content. The question was, tell me a short joke about programming. The answer was, why did the programmer quit his job? Because he didn't get an arrays. Acha. Oh, arrays. Oh, sorry, that's nice. Okay, he didn't get a raise. That's it. Nice. This is one example you can use to create simple rack chains. Now what we can do is using system messages. Okay, let us use the system message once. Let us see what happens. Run it. Yeah. So what is happening here is that first you're importing the system message from the LangChain code and messages module, this message class. Then we are actually initializing with content one, like content because you are a helpful assistant that tells jokes. Okay, this is the content. Human message is this, and then we're getting like content tell me about programming. Okay, this is human message part, and this is the system message part. Like, what is system message? It is a kind of universal message which it has to follow. Okay, like it has to follow the system message. But human message is something like it can follow, but it can just give the answer to the human message directly. But system message is something like universal rule for the LLM. It has to follow the rule. Okay, that is a human message and system message. Now, if you are passing it as lnm.invoke, we will give the system message here and then the human message, because system message is like human universal message and it is like the direct prompt. So now if you give it, like it will tell about the joke. You are a helpful assistant that tells about jokes, that tells jokes. Now tell me about programming. Okay, it will tell about programming in a very joking way. See, it has told about programming in a very joking way. Next example, let us give this example. Okay, so what will this do? Let us see. Let us run it once. Yeah. So what is happening here is that we are actually doing the same thing here only. Like, here we did system message, here we are doing something with system and human. This is another way of writing the same thing, but with the chat prompt template class. Okay, we are using this class and we initializing with this one, and then we are actually prompt value will be actually this one template person not invoke. Let us see the value. What is this? Message is equals to system message, your helpful assistant that tells jokes. And this is system message and the human message will tell me about programming. Okay, now you got it. Same thing only. Here also we got the same thing. Like, okay, just wait. I think here, yeah. Human message, system message. Here also we're getting same thing like human message, system message. Okay, that's it. So now we can do one thing, chain with this template per template. Okay, chat prompt template we can use it in the chain also. Like, let me just do it once. Yeah. So here if you do it once, like persona chain, because the template persona, you can then LLM and then output person. Like, it will first go to the template. Here this template, system message and human message. Human message will tell me a short joke, tell me about programming, and then it will go to the LLM. The LLM will give the answer in response or response format, and the output parser will give the response or content part. Okay, that is the thing. So let us run this once. See, we get the final answer. Yeah, see, programming is like cooking a recipe. You need to give it everything. All the answers are correct. I do programmers prefer dark mode because I attract bugs. Okay, nice, nice joke. Now, now what we're going to do is the structured output of the pydantic power. Okay, what is this part? So this is nothing but the power of the pydantic power. Okay, pydantic is a class which we can use actually to validate the models or validate the model's output actually to be more precise. Okay, like we want the output in this structure only and we want this structure only and only. Okay, so what we can do here, paste this code here. So what we are doing actually, we are actually importing the base model class and the field. Okay, field function or field class, and then what we are doing is that we are actually defining this class which is mobile review, which will inherit the base model class, and it will have the following following extra parameters attributes. Okay, what are the attributes? Phone model. It will be what type? String, string. And what will it contain? The field. The description of the field will be name and model of the phone. So this description will go into the LLM, and the LLM will then give the name and model of the phone, and it will parse the name and model from the text or the review text, and then it will give the final answer. Now, let me show you the magic of this. Like this, these are for the model validation. Okay, so let me show you one example. Then it will become very clear to you all. Let me show you one example here. Okay, yeah, see, yeah, structured output. And like what I'm doing here is structured LLM equals to LLM dot with structured output. Now, what is happening here is that this LLM is the normal LLM object which we defined here. Okay, I hope you remember this one. This object, yeah, chat drop. Now, what is happening here is that we are giving it some extra additional powers using Pydantic. Okay, we are giving it structured output power with Pydantic to parse the output into this structure. Now it will give this structure like structured output object equals to phone model equals to Galaxy S21. See, here it is Galaxy S21. See, so what it will actually do, it will review this text, and it will give the output in this following format. That is the only thing which you want. Okay, simple. See, phone model, pros, then cons, then summary and everything. So that is it. And if you print the pros also, we can just output of the pros. We can access the attribute dot pros, and we'll get the pros. That's it. Okay. So let's have the Pydantic power. Now let us go to the RAG workflow. Okay. How do actually RAG work in this kind of documents? So let us understand this. Okay. So building the RAG knowledge base. How we can build the RAG knowledge base? Just copy paste this one. Copy paste. Okay. So what we are actually doing here is we are actually loading the documents from here. So the PyPDF loader is for PDF document to text document, and docx to text loader is for doc document to text document. Okay, these are for this purpose. This is a very simple Python function in which you are actually loading the documents, and if it doesn't exist, if they do not exist, we are giving exception. Okay, simple. Like if it is a PDF, like if it ends with PDF, we will actually load with the PyPDF loader, and if it ends with the doc, we will load with we will load with the doc to txt loader. Okay, that's it. And the folder path will be data. Okay, now this is a very interesting thing. Since we do not have the folder path here, so we will create one folder here, data, and we will need some data here, right? So let me just copy paste the data from here once. Just let me do it. Okay, just let me copy paste the data once. Okay, you will need to make a data folder here in the notebook folder, and from the data folder you need these things. Okay, 1 2 3. Okay, sorry, my bad. 1 2 3 4 5. I have 5 files there. So let me copy paste the files from there to here. Okay, just copy paste the files. Yeah, now I can show you this one. Yeah, so yes, this is my fictional data folder which contains some data which I have generated from ChatGPT. Yeah, this data was generated. It is not some company, because it is a fictional company. Okay, normal company, like it is generated company. It is not, there is no company like this. Okay, this is just for testing purposes. So now it will just go into the data folder and will load the documents from there. Okay, simple function like load documents from the data folder. Folder path equals data, and if we'll use a load document function, which will use the doc to txt loader or PyPDF loader. Let us see how it loads. Let us load it. Yeah, loaded 5 documents in total. Nice. So now we will use the splitting of documents. Now what we will use? Recursive character text splitter. Okay, to make it in chunks. Okay, and the chunk size will be how much? Chunk size will be 1000, and chunk overlap will be 200. Okay, and the length will be on the basis of length of the document. So if documents is present, only split if documents are loaded. Okay, if it is not loaded, then split no documents to split. Okay, this will be returned. Let us see how many documents was loaded and how many chunks were made. Okay, let us see. Okay, split the documents into 5 chunks. Okay, that's it. We loaded into 5 chunks. Next we will use the embedding model from nomic embeddings. Okay, to create the embedding vectors. So yeah, we will use the nomic embedding requires nomic API key. So yes, we will load the nomic embed text version 1.5 from nomic embeddings. This is the model which we want to use. Okay, so let us just run it once and let us see if the model function is loaded or not. From LangChain nomic import nomic embeddings class. You will initialize with this model equals to this. Nomic embeddings initialize. Let us see if it is initialized or not. Yeah, nomic API key requires, but it is nomic embeddings initialized. So the API key is working. Okay. Next part, storing in ChromaDB. Let us. Okay, the next part is ChromaDB vector storage. Okay, nice. Let us understand this part also. So from LangChain Chroma, there is a function, there is a module package of LangChain known as LangChain Chroma. From this module, we are importing known as the class known as Chroma. Okay. So the vector storage equals to none, we are initializing with none. So if there are splits or chunks in the documents, and if embedding function nomic exists, like here we declare the embedding function, the embedding model we declared here. Embedding function nomic equals to embedding nomic. If it exists, then only to collection research docs nomic. The directory will be ChromaDB research nomic, and we will initialize in the database there. Okay, the vector database there. Let us initialize it. Chroma vector store ready for using nomic embeddings. It should print this one. Okay, Chroma vector store ready using nomic embeddings. Let us see if it printed this one or not. Let us see. It is attempting to create a load ChromaDB at this one. Okay, so where Chroma vector store ready using nomic embeddings. So it is now ready. Okay. Now let us see the next part. What is that? Now we'll create a retrieval. Okay, retriever. Okay. But before creating the retrieval, let us see what does it actually look like to retrieve some documents from the vector store. Okay, let us see. If vector store object is there, then query only when was feature take or founded. This was the like in our document we had like company profile, and in company profile, it was a company name was Future Tech Corporation, founded 2012. Let us see if we can get this file as well, like company profile. Okay, because there is a relevant chunk here. Let us see if we can find that file also. Yeah, company profile.pdf. It will find the relevant data here only. Okay. Similarity search for when was Futuretic or founded. So now see, it is getting the top two search results, and the top result is company profile. So it is working very correctly. But the similarity search is using here, it is actually nothing but the L2 norm. I can show you here also. Let me just open it once. Similarity search. Okay. Where is it? Okay, I think here. Yeah. So you just see the documentation of ChromaDB. Here you can see configuring Chroma collections. Okay, here you can just see the default value is square L2 norm. Okay, the default is square L2 norm, but you can use what is the formula of square L2 norm? It is nothing but summation of ai minus bi whole square. Now, if it is root over, then it is like norm. But since it is squared, it will be like square of the root over. Root over will cancel, and so we get ai minus bi whole square. Okay. We can also use the inner product formula or the cosine similarity also. Now, what is cosine similarity? It is nothing but 1 minus cosine distance. And cosine distance is this formula. Okay. You get it? Yeah. So you can just play with this configurations and formulas. You can just get a glimpse of this one. Okay. So yeah, that is for ChromaDB docs. So here for this one, it is using square delta norm. Okay. So for this one, it is using square delta norm. It actually works better if you use square delta norm, but you can use cosine similarity also. Next one is using a retriever. Okay. So let me just copy it here. We will create the retriever which will automatically fetch the most top results or the top two results. Yeah. Retriever created. Just let me just run it once. Yeah, retriever is created now. Now we can automate the retriever to fetch the results automatically for our LLM. Okay, before building the rack chain. So now let us build the basic rack chain here. Let us build it. Okay, so from langchain.schema to runnable. Runnable is nothing but a class to create runnable chains. We are importing the runnable pass-through class. Okay, so if the retriever is created and the LLM is present, we will print the building basic rack chain. So this is a template which we already used before. Following context. Context is nothing but the relevant chunks, and the question is the query. Okay. So we will the prompt drag will be chat prompt template dot from template template drag. And what is the format documents here? It is a function or a helper function which will actually convert all the retrieve relevant chunks into one chunk, and then it will pass that chunk into the LLM as context. So for that reason, we are using format documents, because we can't pass top two search documents as one document. So for that reason, we are going to convert them into one document using this separator. Okay. So dot join doc.page content for doc in docs. For that, we're converting into one document, and then we're calling the rack chain. We are making the rack chain using context as retriever, and then format docs. We're getting the context from there as a whole document, and then as one chunk, and then you're passing the question as runnable pass through. It will actually take this question, and then it will give that one to the this part. Okay, like this part, it will give that one to this part, and then it will go to the prompt tag. It will create the prompt tag. It means it will give the in a very structured way, and then it will give the prompt LLM. LLM will give the output, and then output parts will give the response that content. Okay, so that is a basic reaction created. Now we will try block. We will actually find out whether it works or not. So print invoking basic reaction, and then we'll invoke it, and then we will see the question and answer. Okay, now let us test it once. Otherwise, we will not understand it very well. Let us test it. Yeah. So it is given the correct answer. Now, what is the question? When was Project Car founded? Okay, and the answer is 2012. So the answer is correct actually. See, 2012 was. So it is given the correct answer. So our rack chain is working fine. Okay. So now these are kind of like question answer rack. Now, if you want to build a chatbot, you will obviously need memory, right? For building rack chatbot, you will obviously need memory because chatbots require memory. Without memory, it will be like normal QA system. But if you want to build a chatbot, you will of course need memory. So for that reason, we are going to show you some demo here, which will actually contain some memory also, the chatbot system. Okay. So let me just show you one simulation of chat history. Okay. So notebook chat history goes simple empty list, and this is the first question. Now, if the question's answer already exists, it will take that answer which is already existing in 2012, or else it will just write feature tick corpus 112. Okay. But here, if you just print this chat history, it will print like 2012 only. Okay. Let me just show you once here. See, system human message अच्छे when was feature tick are founded, and here like if you get the AI message, it will content until 2012 because it already existed, right? This answer already existed, so it is existed, so it took that answer only. Otherwise, it would take this answer. Else, this answer would have been passed. Okay, but this is just for simulation. Now let us go to the next step. Okay, where we are going to build the database for storing all the document logs. Okay, so for that you're going to use SQLite 3. Okay, it is based on SQL database. The database name will be ragapp.db, and then get DB connection with very simple functions. You can just look at it later also. Okay, so very simple functions. I've given the like it's a very simple functions like what are they doing? It's like creating a connection here, and then creating giving all the rows, and then here what is doing creating the application log table, and here we are inserting documents in the table. Okay, inserting rows in the table, and here we are getting the chat history from the rows, and here we are just getting the application logs table. Okay, so let me just run it once. Okay, the previous question was run. I think previous cell was run. Yeah. So let me just run it once here. Yeah, so it ran. Okay, nice. It created the database. I think now it is created. Yeah, ragapp.db is created now. Perfect. I got it. So next is create application logs. Now we can see how it is working. The application logs. Okay. So using the database functions defined earlier, like we can just see the real life simulation of how a database works. Like it will first storing or retrieving history with a DB. Then we have the using session ID. It will create a unique session ID using unique ID. Okay, universal unique ID, and then it will create like these are like sample questions, like sample question, sample answer. They insert the application logs, session ID DB, and then question answer and the model name. It is also sample. Okay, we are not using any real data here, but when we will create the app, then we will use the real data. Okay, so let me just do it once. Insert and run it once. See. History retrieved from DB, role human, content what is feature tech, AI then again history will be human, and then again AI. So now it is working perfectly fine. Okay, it is the simulation is correctly created. So now we can go to the building the history of a rack chain. Okay, this is the final rack chain for the Jupyter notebook, and then we go on to the RAG application. Okay, the RAG chatbot. So let us see what actually happens here. So what is happening? Our message placeholder is just to give the chat history. And then here actually as you can see you're placing the chat history here. So message placeholder used for chat history. and then this actually create history of a retrieval chain and create history of a retriever. Okay, these things I used to create the history of a retrieval chain, and then you are creating the create the stuffed document chain for creating the document chain which are stuffed into one document. Since I told previously, na, we cannot pass two documents as one document. So what we're going to do, we have to convert them into one chunk and then pass it. So for that, we are going to use create stuffed documents chain. Okay, so yeah, you can use it. Here, step one will be actually contextualization of the prompt. Like you're given this prompt, given a chat history and the latest user question, which might reference context in the chat history, formulate a standalone question which can be understood without the chat history. Okay. Do not answer the question, just reformulate it, and then otherwise return it as it is. So you can understand this one. And then we have the here create history of a retriever, and then the Q&A prompt history, and then this part is for creating this staff document chain, and then you create the retrieval chain. Okay, we have to create the retrieval chain with a history, chat history, and then this part is created. Now we can just reformulate the question and see how it is reformulating, and then print the reformulated question. Okay, just let me just run it once, and then we will see the answer. Okay, so let me just run it once. See, now it is given the perfect answer. Like, see, the first thing was history of a retriever created, question answer chain created, full history of a exchange created. Okay, now the reformulated question will be what was the question which we asked? It was where is it headquartered? Okay, just this question. But what is the reformulated question? It was like, see, what is the headquarters location of Future Corp? See, I didn't give this information. It took it from the chat history and then it made this contextualized question. Okay, so this is the power of actually chat history of a retrieval. So invoking full question with history, we will get this answer. Okay, San Francisco, California. So that is the part. It is the perfect answer, I think. Let me see it once. Data, company profile. You will just see it here. Yeah, San Francisco, CA. See, so it is even the perfect answer. No issues, I think. Yeah. So this was the Jupyter Notebook part. Now we'll go on to the RAG app part. It is very similar, just a little bit of tweaks, and then the RAG app will be created. Okay, the RAG chatbot. So any more doubts here? I think there should not be any doubts. Like, let me just see the chat once. Uh, okay, nice. Grok done. Okay. So this was the part of this one. The experiments that IP and me. Now we will create the application. Okay. So this is a very important part. Now I think I should show you the application also. Okay. So we have done the first step, generate the project structure. This part is done. Dependencies, this part is also done. Setup shell script, this part is also done. We have created the environment, virtual environment. And this part, I think this part is also done. Keeping git clean. Yeah, git ignore we have already written here. Git ignore, yeah. Then .env also we have done. I will not show you my environment variables. Okay, no issues. Then we have the core logic, the utils directory. Okay. So now let me open this part, the utils directory. So here we will have the backend logic. Okay, so let me just write the utils and then let me just write this code here once. Utils slash pydantic models. Okay, now it is just for output validation. Just create this one. I'll just tell you write the code first and then I will explain. Okay, so what is it doing actually? It is first creating the model structure, model name. Then it's creating the query structure, the query response structure, document info structure, like how it will store the document in the database, and then the delete file request. Now, if it has to delete the document, then how it will delete the document using the file ID. Okay, this is the identity thing. So I think this is very short. I think okay. Let me keep it very short and simple. I will not go into the technical terms here. I'll make it very simple and short for you all to understand. Okay. So pydantic models is done. Now let us go on to the next part, which is actually DB utils. Okay, let us copy paste this one into DB utils. Okay, just copy paste it here. What is actually doing? Okay, let me just explain it once in short. So first you are actually creating the DB directory, data directory. Okay, it will create the data directory. Then it will create the database name as ragapp.db. Then DB path as OS path. It will just join the path from DB directory and DB name. Okay, data under the data it will have ragapp.db. It will first initialize the database. For this function is written. The application logs table. It will create it. Okay. Next, it will get the establish the DB connection, SQL database, and then it will insert the application table logs. Okay, and this is for actually getting the chat history from the application logs, and it is for inserting the document or record. Okay, the file which will be uploaded in the document the in the database, it will be actually inserted into the document records also. Okay, for that reason we implemented this function, and then we have the delete document record for deleting the file. Okay, and then this function is actually written required for getting or fetching all the documents. This function. Okay, I think now it is good to go. Now we can just leave this file. Okay, just close this one. Now next what we have is, I think, langchain utils.py. Now chroma utils.py. Okay, got it. Chroma utils.py. Let me just write it here. All right. Yeah. So it is right. Perfect. So chroma utils is nothing but the utils for the ChromaDB database, web test database. Okay. So what is it actually doing? It is creating the embeddings using langchain chroma or no, langchain nomic. And then what is it doing? It is actually getting the dimensionality of the nomic embeddings. Okay, and then it is passing on to the get embedding function. It will get the embedding function from there, and then vector store will retrieve from there, and from there it will initialize the vector store and it will check if the vector store is ready. If it is ready, then it will actually use the text spreader to spread the documents, and then it will load the spreaded documents, and then it will index the documents to chroma. And then if it is possible, if it is fine, then I think it is all the done. All things are done. And then delete documents on chroma. It is another function. It is used for deleting the documents from chroma. Like if you want to delete one document, since our chroma database is limited, if you want to delete one document, you can just use this delete documents from chroma function. Okay, so this part is also done. Then let's move on to the next file. Our next file is, I think, langchain utils. Yeah, this file, langchain utils.py, space area. Yeah, so this file, so can you see it here, like rag app utils langchain utils.py. Okay, so why is this required actually? So it is used to create the rag chain. Okay, as I told you there, how to create history of a retrieval augmented generation chain. For that reason only this what is required. You can just study it on your own. But for short overview, I'm giving you a very short overview. Like it is actually creating everything like using langchain only. Okay, the rack chain and then the nomic embeddings, it is verifying it, create subdocuments chain, getting the chat history, and then creating retrieval aware chain, a history aware retriever, and everything is done, and then create the retrieval chain. It's very simple. Okay, we did it previously also. So here it is created in the retriever chain, and after this chain is created, okay, line chain utils.py, the chain is created. So now we are good to go with the front end. I think the back end is already done. The chain is created, everything is done. So now let us move on to the user interface, the app directory. Okay, let us open the app directory now. We're already short of time, 9:30. Okay, my God. Okay, the chat interface. Okay, the sidebar is the first one. Okay, let us click on the sidebar.py. Sidebar. Have to create the sidebar. Okay, just let me create it once. So this is nothing but the helper function to create the sidebar of the streaming tab. You can just look at it once. It's very simple. Like it is used for getting the nomic API key, graph API key. Then it will give the session button there, session ID, and then insert document, delete document. Everything is there. Once I will show you the interface, then you will try to integrate with this code. Okay. Now I think it might be very difficult for you to understand this part, but once you get the interface, now it will be very easy to understand this part. You will be able to see this part also. Okay, so this is the sidebar.py. Next part is the chat interface, I guess. Yeah, chat interface.py. So let us create the chat interface. So this is the main chat interface. I really actually having the chats with the rack chatbot. Okay, so here to the display chat interface, like a nomic API key, grok API key, model, session ID, everything with this. Okay, the rack chain and all those parts, then logger, then inserting application logs. Once we have created the chat, we will insert the application logs after each chats. Okay, after logging, we'll use some application error. If there is an then we will print this error also, okay, using logger.info or logger.error. So this is the chat interface, and now you will have the final file here, which is nothing but the mains UI script. This is streamlit app.py. Okay. So yeah, this is more or less of this. Just paste it here. I think now it is done, I guess. Yeah. Okay, now two files are still left. I will show you it once. But let us understand this part once. Okay. What is happening here? So this part is actually for the Streamlit part, because Streamlit doesn't support ChromaDB native ChromaDB. For that, we have to use this MySQLite 3 also, I think. Patch SQLite 3 with MySQLite 3. Yes. So Streamlit doesn't support SQLite 3. So for that, we are actually patching it with MySQLite, and we're not found. 200 system SQLite 3. Okay. That's it. Here we actually, what we are doing here is actually we are actually setting the rag app directory, this rag app directory, to the root directory path. Okay. For that reason, we're actually passing the rag app directory to the root directory path. That means this directory rag app, it will be the root directory for this project, not this project, not this directory. Okay. So this directory is the root directory, and after this we are just initializing, importing the core components of Streamlit, and then initializing the database, and then the Streamlit app logic. Then there's a display sidebar and display chat interface. Okay, this is done, I guess, more or less. Next, we are using this pipeline, I think. Yeah, pipeline. Exception part, let me just fill it once. Exception. Yeah. This is a custom exception class which you can just make for getting the line number and file name on the exception. And the error message. Okay, you can just print it once in a custom exception class. And here I will use the logger class. So yeah, pipeline slash logger.py. So here this is a logger file into content where you can just create a logger application which will actually save your logs in the log file. What is the name of the log file? It will be datetime.now, means the current date, in XCRF format, in this format dot log. This is the name of the file. Okay, so this is a log file. So this can be it. I hope this is done right now. The logger part is done. Everything is done. Now we can just run it once. I hope it will run. Yeah. I hope the app is created now. Let me just run the app once. Time terminal. Okay. So now I think we can just run the app. Okay. So Streamlit run. Then okay, one thing which you have to ensure before running it, you have to activate the environment, virtual environment. Okay. So what further what you will do is env slash scripts. Okay. My bad. Oh my god, what is happening? I don't know. Okay. env slash scripts slash activate. Okay. This will activate your environment for this app. Okay. And then what you can do, you can just run this Streamlit run, and you can just copy this relative path from your Streamlit app. Copy relative path. This is the main UI interface. Okay. And then click on this, and then you can just run it once. Let me just see why everything is fine or not. Chat interface is fine. Just click on once. Okay. It is complete. I think, yeah, it is complete. It is also complete. It is also complete. This part is also done. This part is also done. This part done. This part complete. Complete. Okay. I think this should work. Let me just run it once. Streamlit run and app. Okay. Let me just run it once. Yeah, so it is working, I think. So yeah, it is working. So now I have to give the API keys here. Let me just copy the API keys once and I'll provide it here. Let me just open the .env once. .env grok API key. Let me copy grok first. Grok is done. And the nomic API key for the nomic model. Nomic copied. Nomic done. Okay. We're going to use Trauma 3.18 billion instant. We are going to load some documents also. Let me load this document. Assignment 4. Okay, let me just load it once. Upload document. Yeah, it is indexed. It is uploaded. Okay. Now refresh the document list. Okay, done. You can see this document here, right? So let me just ask some question from assignment 4 only. Okay, where is it? I think. Okay, no issues. Let me open our assignment for once. Assignment 4, let me open it once. Guys, just wait. Yeah, so this was assignment 4, okay? So let us ask some questions and answers, okay, from this document. Though the answers are not here, but let us try it, na? If the LLM can give the answers also. So let us try something. Give the first 10 questions in structured format, okay? Give the first 10 questions in the first 5 questions in the document in ordered format. Let us see if we can give it or not. Yeah, so it gives the first 5 questions. You can just see it from here. See, it just gave the first 5 questions. You can just match it once. Like select all employees from maintenance and development department. It is matching. Display all employee names and salary who's that is the minimum salary of the employee. Yeah, it is matching also. More or less all the questions are matching. Right? Let us just wait. Yeah. So these questions are matching, I think. Yeah. You can just see these questions are matching. First question is this, second question is this, third question is this, fourth, fifth, and all questions are matching. Now let me just ask another question. Can you answer these questions? Because these questions are because the answers of these questions are not in the RAG knowledge base. So let us see if we can answer or not. I think it will not be able to answer, but let us see. It might be able to answer. Yeah, it is actually able to answer because it is actually using its own knowledge base, pretend knowledge base. So it is actually able to answer. Now if I just write it in a structured format, it will get the previous questions context also. Yeah, see, it will work. Yeah, see, it is giving the answers in structured format. Also, the explanation is also given. So now see how much efficient this model is. So now this part is already almost done. Now only one part is left, the deployment part. I'm just going to show you the deployment very quickly. Okay. But for deployment, what you can do is this part. Okay. For deployment, what you can do is you can create a first GitHub repository. Okay. So let me just create a GitHub repository from VS Code only. Okay. Initialize repository. Let me just do it once. Okay, let me see which of the files are being going to the repository. I think these files are good to go. These are also good to go. Nice. Okay. All right. These files are good to go. Initial commit. I think these files are good to go. No issues are there. The .env should not be there. Yeah, the .env is not there, I think. Okay. So just initialize the repository. Commit. Just let me once see everything is fine or not. Yeah, it is fine. Commit. Yes. Okay. Now if you want to just see everything is committed except this .env, I think, and the env is also not there. Nice, perfect. .env is also not there. Perfect. Okay. So now the next part is you need to publish this branch as a public repository in GitHub. Okay. So just do it once. Publish a public repository. I said what is WH. Okay, got it. Public repository. Just wait till it uploads it on GitHub. Now if I open it in GitHub, see. Now it is set up. Okay. So now what we're going to do, we are going to deploy this Streamlit app on Streamlit Community Cloud. Okay. This app will now be deployed in Streamlit Community Cloud. But before that thing, one thing I have to change. I told you previously also. This requirements.txt. This one should be used for Streamlit deployment. So this one should be changed and then it should be committed also. Updated requirements.txt. Requirements.txt. Okay. Simple commit messages should be there. Simple commit messages. Updated requirements.txt. Commit. Yes. Now it should work. Sync changes. Perfect, I think. Now we can deploy it in Streamlit. Okay, this step is necessary to actually deploy it. Otherwise, there will be a issue with ChromaDB and SQLite 3. Now we can just deploy it once. Okay, where it is? I think this one, this was, where is it now? Okay, the GitHub repository, where was it? Yeah, this one. So now we are going to deploy it in Streamlit Community Cloud. Just click on deploy here and the local application, then deploy now. Okay, and then just do one thing. Just give me 1 minute. Yeah, nice. So just here, what are we going to do? Rack chatbot HWH main Streamlit by Streamlit app.py. I think this is perfect. App URL will be rack chatbot HWH. Rack chatbot HWH. Okay, perfect. Main branch. Okay, I think this step is done. I think everything is, I think, perfect. Any more changes should be there? Main branch, everything is done. Okay, and now I think I can publish it in Git Streamlit Community Cloud. Yeah, so let's deploy it. Let's see what happens. If it crashes, then we'll have to fix it. Okay. This file actually is not necessary, so we are not going to work with this setup.py. It is actually not necessary for this project. So let the app cook in the oven. Okay. Let us wait for some time. It will be ready, I think. Let us see the logs. Yeah, it is working. Spinning up manager process, provisioning machine, preparing system. Yeah, now it is working, I think. Process dependencies. Now it should be good to go. Nice, it is working. Okay. So let us just put the API keys here. Choose your own, obviously. So now just give me a moment. Let me upload the API keys from this file. Okay. So the grok API key will be this one, I hope. This one. Never save. API keys, of course. And this is the nomic API key. Never save. Never save. Okay. Next is document. I'm going to upload the same document only, like not from here. Okay, same document. Let us see. Yeah, so it uploaded. Okay, nice, no problems. Refresh document list. Now let us see if we can answer the same questions. What are the first 10 questions in the document? In the document. Yeah, so it is actually working correctly. So this was the application which you can build, and I'll share the link with you guys also, this application, as well as the GitHub repository of this application. Okay, all the links will be shared. So this was the complete application which I was talking about today. Okay, about this RAG application, RAG chatbot. So this was the whole application. I hope you enjoyed it. But now let me show you one more thing. This one is as like a small sample project by one of my juniors. His name is Rishi Pal. He has actually built one sample project here. I'm going to show you one of his projects. Like it is a very unique project. I'm going to show you this. Okay, so it will take around 2 to 3 minutes. Just you can just create your own projects from this motivation. Okay, like I built this project from this. You can just create this kind of projects, small projects for your own use cases. Like this one was made by Rishi. It's a very unique React chatbot. Okay, like it can you can upload your PDF files here, and then you can just chat with them. Like here, I chatted with some of the PDF files of mine, like assignment 4. These are the chats. You can see it, and the notes too. These were the chats. And then one of the very unique things is that it's like you can just visualize the PDF also, and then you can just verify the questions answer side by side. Okay, so this was one of the most unique features we have found in this app. So this app was actually developed by Rishi, one of my juniors. And so you can also develop applications like this and then showcase them and publish it in GitHub also. Okay. So that was it for today. I hope this session was interesting. And this was the application which I developed. Okay. The Streamlit application. And yeah, that was all for today, I think.
Yeah,
So
nice one, Mark. Nice one.
thank you,
From
Tagnik.
full deploying everything from starting
Yeah,
from the
everything.
scratch,
Everything I
writing
tried to show.
everything. So yeah, it is really nice of you to have this much long energy to take this much long session. Hopefully, it will be beneficial for everyone. So yeah, thank you everyone for joining. Thanks a lot to Mayuk for showing everything from scratch to writing a full thing and using Streamlit. That's the easiest one to deploy these things. Yeah. So thanks a lot, everyone. Okay, thanks a lot, Mayuk. Maybe in next other session we'll see.
Thank you. Thank you. Thank you.
Okay. Good night, everyone. Goodbye.